Okay, so this video is for Sipser exercise 4.3. This is in the decidability portion of your textbook. This question asks us to show that all DFA is decidable, and all DFA is defined by some machine A, where A is a DFA and its language is all strings. So the easiest way to approach this is to use tools that we already know. So in class and in the book, we heard about eDFA, which tests the emptiness property of a language. So Sipser defines eDFA as some machine D where D is a DFA and its language is the empty set. So how can we use eDFA to solve all DFA? Let's think about it. So if you have a language A in all DFA that has to have every single string, the opposite of that language will contain nothing. So the language of A is all strings, therefore its complement must contain nothing. Complement. Okay, so if we can determine if A contains nothing, or the complement of the language of A contains nothing, then we know that the actual language of A contains everything. So how do we design a Turing machine that will actually do this? Let me scroll down here. So this algorithm, we have to create a DFA, we'll call it CompDFA, that recognizes the complement of the language of A. We'll pass this DFA to the eDFA to determine if it's empty. So if eDFA accepts, then the complement of M is empty, which means that the actual language of M contains everything, so we accept. If eDFA rejects, then the complement of the language of M is not empty, so there was some string in sigma star that L of M did not have, so we reject. I'm going to show you a picture now that will explain this even further. Okay, so we pass our input A, our machine A, into all DFA. All DFA generates this CompDFA, which is actually the opposite of the language of A. It passes that to eDFA. eDFA tests the emptiness. So if the complement of the language of M is empty, that means that the actual language of M is sigma star. eDFA accepts, so we accept, which means that L of M is sigma star. If eDFA rejects, then that means that the complement of L of M is not empty, which means there was some string in sigma star that the language M did not have, so we reject. So that means L of M is not equal to sigma star. And that completes the problem. If you have any questions, please leave them in the comments.